Today let's talk about transistors. The full name of a transistor is bipolar junction transistor, abbreviated as BJT. Because it is made from semiconductor crystal materials, it is also called a crystal transistor. If we use one word to describe the function of a transistor, it is amplification. For example, in a standard transistor amplifier circuit, very weak electrical signal is applied at the input. Through the transistor's amplification, the signal waveform is amplified by tens or even hundreds of times. This allows it to drive a speaker or activate a relay. This is the amplification function of a transistor. To make this easier to understand, let's use an analogy of water flowing in pipes. We compared a diode to a check valve in a water pipe. When water flows in the forward direction, the valve opens. When water flows in the reverse direction, the valve closes. A transistor, however, can be compared to a control valve in a water pipe. It is a control linkage on top of a check valve. By moving this linkage, the valve opening can be adjusted. This controls the amount of water flowing through the pipe. Now, let's add a branch pipe. When water flows through the branch pipe, it pushes the control linkage and opens the valve. Water then starts flowing in the main pipe. As the flow in the small pipe increases, the valve opens wider. The flow in the main pipe increases accordingly. When the small flow fluctuates, the large flow shows a similar waveform due to the linkage. It is easy to see that a small flow is used to control a large flow. This clearly demonstrates amplification. Now let's return to the transistor. The circuit symbol of a transistor is shown here. It is clear that a transistor adds a control terminal to a diode structure. This control terminal enables amplification. Depending on the added material, transistors are divided into N and NPN types. If a P-type material is added to the original PN junction, an N structure is formed. This type is called a N transistor. If an N-type material is added, an NPN transistor is formed. N and NPN transistors play different roles in circuits. Sometimes they are used together. We will explain these in detail in later videos. Next, let's look at some typical transistor applications. The first is a microcontroller driving a relay circuit. Most microcontrollers operate at 3.3 volts. Their GPIO pins typically provide about 10 milliamps of current. They can directly drive LEDs or small signal relays. However, relays with higher voltage or power cannot be driven directly. In this case, a transistor amplifier circuit is needed. For example, in automation systems, intermediate relays often have a 12-volt coil. The transistor circuit provides power amplification. It also enables control from 3.3 volts to 12 volts. The second application is an audio amplifier circuit. When singing or recording videos, we use a microphone to capture sound. The electrical signal from a microphone is very weak. It cannot be processed or drive a speaker directly. It must first be amplified by a transistor circuit. The third application is a radio circuit. Here the microphone is replaced by an antenna and tuning circuit. The tuning circuit selects signals of a specific frequency from the air. This signal is extremely weak and requires multiple amplification stages. Eventually, the speaker produces sound and the broadcast can be heard. From these examples, we can see that transistors are extremely important in modern electronics. They are also the fundamental building blocks of integrated circuits. We often describe a chip by how many transistors it contains. The number of transistors defines the scale and performance of an integrated circuit.